It's recording. Here we go. Exercise 2C. Have a pen or pencil ready to take notes. Thank you. Let's not speak while I'm speaking. First thing in exercise 2C is you need to identify 3 types of triangles. There's many more. There are many more types, but to start off with, these are the 3 most common problem-solving ones. Starting off with the first one, let's look at the symbols. When you're doing exercise 2C, I do expect you to draw the diagrams. I expect you to draw diagrams because the symbols is a practice to learn the notations for it. So here, what do these notations mean? Here I've got 1 dash, here I've got 2, here I've got 3. What do those dashes mean? Can I have a show of hands if you know? Yes, Carissa. Good. So when you put 1 dash, you're saying that is the length of 1 dash. If this has exactly the same length as this one, they would use 1 dash. But because they're using 2, what they're trying to say is this length from here to here is different to this one. That's why it's 2 dashes. Then the same thing over here, this is 3 dashes to say that this length is different to all 3 of them. That's the idea. So you always look for the symbols because the notations matter. So these lines here means length. Then your angles, there's a couple of ways to do it. You can use different symbols. Notice how they use different symbols to say they're all different angles. You could also use another way to do this. You could also do 1 curve for one area, 2 curves to say that that's a different angle, and 3 curves to say that's a third different angle. Okay, so there's 3 different ways to do it. Now, which type of triangle, in your current knowledge, which type of triangle has all 3 sides that are different and all 3 angles that are different? Scalene, very good, write that down. Scalene triangle will have different sides, so write that in, different, and all have different angles. Do you need a pencil?
No, I've got one.
Okay, well, let's write it down.
I have a pen.
Well, I've got a pencil. Would you like a pencil? Okay. When you're ready, you should copy it down. Next one. Next triangle. We got the first one where all sides and all angles are different. What type of triangle have 2 sides the same length and 2 angles that are the same? Notice the notation. They both have 1 dash and they both have 2 curves to signify that these 2 angles are the same. What is this one called? Hands up if you know. Starts with I. Isosceles. Thank you, Belinda. So, isosceles. Okay, that's how you spell it. Write it down. Isosceles triangle. They both have 2 sides are the same and then 2 angles that are equal. That's one of the most common problem-solving triangles, so make sure to know that one. Aqualia, can you help me close that door? Because I have the aircon on. I just don't want the air to go out. Yeah? Can you come up here? Yeah, grab this one. Nikki. All right, and the last one, the last type of triangle, which we might all know, which one has all the sides the same and all the angles are also the same? Starts with E. Hands up if you know. Yes, Charlie. Okay, what do you know it though? Triangle that has all sides the same?
Shut up, Xavier.
Equilateral. All right, that's about maybe the 4th time you guys have that issue. If you guys can't sit next to each other, I'm happy to move you two so that Matteo, you can be less annoyed with Xavier. Would you like to move? Would you like to sit next to him?
I want him to move.
You want him to move. Xavier, would you like to move because apparently you're distracting Matteo? No? All right. If I hear Matteo say it again, I'm going to move you, okay? Equilateral. Write that down. Equilateral triangle. Here we go. We've got scalene, isosceles, equilateral. Make sure to write that down. Matteo, this is my 2nd time asking you. Please copy this down. Did you want to go to middle school office instead to rest? You have an option. Either you participate in this class, you copy notes so that you got something to refer to, or 2, you can go rest at the middle school office.
Can I actually do that?
Yeah, I'll send you off. All right, let's go. Pack up. I'm going to send you just over there. You just take a break. I'll pause the video. Yes, it is now recording again. All right. Whoops. What's happening there? Good. All right, let's begin. So, part of your notes you should have. Eyes and ears towards the board. Thank you. Thanks, team. Have a pen, pencil ready. So you got types of triangles. These are your 3 types of triangles. And we know that all the angles in a triangle, if you add all the angles together, it should add up to what? Hands up if you know. Josh. 360 degrees. Fill this in. All angles in a triangle must add up to, oh sorry, not 360, 180. 360 is a quadrilateral. I got confused there myself. It's 180 degrees. Now, the last theorem here, this one could be useful when you start to get to the problem-solving ones. There is a proof for this, but I won't prove it yet. You can memorize this one, okay? This is called the exterior angle theorem. And how it works is, usually when you have a triangle, it's only 3 sides, true? So that means you've got 3 angles. But when you extend one of the lines, say you extend this line a bit further out, it creates an obtuse angle. Okay, it creates a much larger angle. So this obtuse angle, or what we call an exterior angle, is equivalent to the opposite 2 angle, because there's always 3. The one that's connected to, we don't count that, but we say that this obtuse angle, let's call it, if this was 150, then these 2, A and B, must add up to 150. Okay, so A and B will add up to whatever that exterior angle is what I'm saying. So I can draw another triangle. If I extended the bottom line instead, then this exterior angle, this outside angle, is equivalent to adding these 2 opposite angles. Those 2 opposite angles, so if I call this A and I call that B, A plus B must equal to the angle on the outside, which is, I'll call it C as an example. Okay, so here, in the diagram I've shown you that Z is equal to X plus Y. There's a proof for it. Some of you can think about it and you can actually prove it through supplementary properties. Otherwise, fill this in. Exterior angle of a triangle is equal to the sum. What does sum mean? What does sum mean? Total, which is another way of saying add. Sum means total, which means add. Okay, so when you add the 2 opposite angles, that will give you the exterior angle. Now what you see there is pretty much the knowledge that you need to demonstrate. That's all you need. The notes up on board at the moment, those are the only ones you need to work out exercise 2C. So let's do some examples. Let's do this one. In a triangle, there are 3 corners, hence there are 3 angles. We've got one side is 23 degrees, the other corner is 110 degrees, but then there's an angle that we don't know. But we do know one thing, that all the angles in a triangle, which there's only 3 sides, this plus this must equal to
180.
180. That was the property. We said that all the angles in a triangle must add up to 180. So what I'm saying is 23 plus 110 plus A must equal to the total angles of a triangle, which is 180. Now you can kind of work this out by guessing it or intuitively. 23 plus 110 gives you 133. Now think about it. 133 plus what will equal to 180? Because that's what A must be. It is 47. Very good. If you couldn't figure that out like mathematically intuitively, you could do the opposite of plus, which you could have said 180, take away 133, and you can type that on your calculator, and that will give you 47 as well. Okay, so the first answer is, therefore, A must be 47 degrees. Okay, let's have a look at the second problem. So the first problem didn't talk about the type of triangle, but notice in part B, the symbols are there. There are 2 symbols here. What's these 2 dashes mean? Hands up. What's these 2 dashes mean? Belinda. Means they're the same. So this side is equal to this side. Now that's where you have to draw back on your type of triangles. What type of triangle is this? If 2 sides are the same, it is not equilateral. Equilateral, all sides have to be the same. Isosceles. Isosceles is the only one with two sides that are the same. Now, in the notes I gave you, isosceles have not only just two sides the same, they also have two angles the same. And if you can see it, if these two sides are the same, it's sort of symmetrical. If I cut this in half, that side equals this side. So that means this angle has to also equal this angle. That's how you solve this problem, because these two must be the same. So double of something plus the 48 should give me the total angle of a triangle. Now let's write that out again. So logically, if I cut that in half, and I can see those two sides are symmetrical, A plus this angle A, which I don't know what it is, plus 48 should give me the total angle of a triangle, which we know is 180 degrees. Now, when you first look at this, this looks confusing. But if you really think about it, A plus A is double of itself. So it means that you're doubling something. You're doubling whatever A is, because A plus A is doubling it. Double of something plus 48 should give you 180. Now, most students do this quite intuitively. What they do is they first go, well, what's 180? Take away 48, because they're thinking something plus 48 has to equal to 180. What's that something? Something plus 48 equals 180. What would the number have to be? It has to be 132. So we can see that 132 plus 48 would give you the 180, but that means double something has to equal to 132. So how would I work it out? What would that number be? Yes, that's good. And that's exactly what you do. You type in your calculator. You know that, well, double of something gives you 132. Well, then that means that something has to equal to half of it. So 132 divided by 2. And again, you can type in your calculator, or you can do it quick maths. 2 into 1, no times. 2 into 13. How many 2's in 13? 6 remainder. 1, and then 2 into 12. 6. So it's actually 66. So half of 132 is actually 66. So some students will skip these steps, and they may already know. They might say 180 take away 48, it's 132, and then divided by 2, you get A. Okay, but what I'm trying to show you is the logic to how you get there. Okay, so writing it down will help you, even if you don't understand what I'm saying right now, it will help you when you refer back to it and you build up your skills, you can then solve it. Okay, so make sure to write the notes down as I'm explaining it, because if you ignore it, then when you want to solve it, you have no way to start off. Okay, nothing to refer to. Again, if you miss out on these notes, they're all on OneNote. Okay, so you can always refer back to it. But there you go. So that's how you solve these two problems. But B, can you see how B was only solvable only if you knew it was isosceles? If you didn't know it was isosceles problem, then you wouldn't know this is A. If you don't know that's A, it was pretty much impossible to solve. So the symbols matter. Let's flip over to the next page. So now I'm going to increase the problem just a bit. This problem here, there's two ways to approach it. One is quicker, and the other one's a bit longer. The longer way is this. What's this little box represent? 90 degrees, because that box means 90 right angle. So 90 degrees. This is A. I don't know what it is. And I don't know what this little corner is, because that's the triangle, right? That's the triangle. Now I can find out what this little corner is, though. How would I find that little angle there? Can anyone see? Very good. Yes, it's a straight line, so hence it's supplementary. Because this angle, it's missing just a little bit to make this 180. Because that's a semicircle there. Right? So I'm just missing a little bit to make it 180 degrees. If that's 161, what should this angle be to make it 180? What would this little corner have to be? 29. 19, very good. So this has to be 19. Now, if you know this is 19, you can now solve it. Just look at this triangle. All the angles in a triangle must add up to 180. So you can say A plus 90 plus 19. Those are the three angles in a triangle, and it has to add up to 180. Let's do it quickly. 90 plus 19 gives you 109. So A, something plus 109 must equal to 180. So what's that something? 71. Very good. Is that what you were thinking? Okay, cool. But that's how you would do it. Okay, so this is the long way of doing it. There is a shorter way. What's the shorter way? Anyone know? You use the theorem. So the one that I gave to you before, I said the exterior angle theorem. Can you see how you've got this shape? It's a triangle, and then they extended one of the corners. This is an obtuse. They told you this is 161. You know this is 90 in this corner. That's the opposite angle. So you're trying to find A. And according to the theorem, A plus 90, so these two angles, if you add them together, it must equal to 161, which is quicker to do. And you can work this one out. 161, something plus 90 gives 161. Or you can do on your calculator the opposite of plus. 161 take away 90. 71. And that's exactly the same answer as the top. One's quicker, one's longer, but this one shows that you know the other properties. This one you need to know the theorem. Okay, so if you don't know the theorem, it's okay. You can still solve it. Both of them is still correct. Obviously, if you know both techniques, then obviously you have more, tools under your belt to solve a problem. Now, the next one looks a bit tricky because they give you a lot of lines, but this is the last problem for today. The first thing is you need to identify the notations. Do you see how they have these two dashes? What does that mean? Two same side. And which triangle has two of the same sides? Isosceles. And again, this is the side that's equal to this side. When I find an isosceles problem, what I do is I try to cut it in half. I find where do I cut it in half to be symmetrical, and hopefully you notice this is the line that cuts it in half. That means this side is equal to this side. That also means if this is A, this is also A. If this is 72, this must be 72. If this is 90 degrees, this must be 90 degrees as well, because it's symmetrical. Whatever is equal on this side is equal to that side. So if you do that, now you can actually see the problem much easier. If I highlight the triangle now, this is your full triangle. And let's draw it again. I draw the triangle again so you can visualize for those who have problems visualizing this problem. This top here was 72. This side must be 72. And then this corner here, it's A plus A, which is double of A. Yeah, so A plus A, you got two of them. So double of A will give you that corner. Now, if you've got this triangle, you can then solve it by doing again. Double of A plus 72 plus 72 should give you the total angle of a triangle, which we know is 180. So let's work it out. 72 plus 72, what does that give you? 144, very good. And if you think about it, something plus 144 has to give you 180. So what should this number be? 36. But remember, this number was double something to get 36. Double of what gives you 36? 18, very good. Or you can halve it. You can say 36 divided by 2 gives you 18. Now that type of problem is problem solving. That requires you to read the notation, identify the type of shape, using the properties of a triangle to solve. I don't expect everyone to be here, but I do expect that everyone can do the first two examples. Okay, so with some practice, questions 1, 2, and 3, you should be practicing this. As you get to problem solving, you'll then be doing more of these kind of problems. Okay? All right, team, I'm going to stop there. I'm going to give you about, it's currently 2:34. I'll give you about 20 minutes before I go around to take a photo of your learning map the way I did for my year 9s. Okay, if you have it, I'll take it. If not, I'll take it the next session. Okay, so here we go.